Natalie explained, I'm going to be giving an overview, just kind of the highlights on each of the water resources that are contained in the report. 3 of the resources are current resources. All 3 are in the proposed taps that WSD is putting forward. So beginning with the first one is local yield. So most people who are familiar with Hong Kong might have heard it called before the barren rock. And that's because Hong Kong lacks any major lakes or rivers for drinking water supply, even underwater aquifer. So the main source of local yield in Hong Kong is only rainfall. And that rainfall is gathered on about 1/3 of the catchment land, and about 50% of all the rain falls on that catchment land. So as you can see, rainfall in Hong Kong can be highly variable. So some years we have quite a lot, some years we get nearly half as much. So it's not a very consistent resource. However, local yield itself stays very much flat. So we managed to collect nearly the same amount despite the changes in rainfall, which means we're somewhat capped on how much we can get. And that comes from the intensity of the rainfall. So while we get quite a lot of rain, if you could collect all of the rain that fell in Hong Kong, you would more than meet the local demand. Unfortunately, most of the rain is contained to just a few months. So you actually have months like January, December, November, where rainfall is actually negative in some years. You evaporate more than you collect. So what that really tells us is it's going to be difficult to collect more local water. There's not much expansion capability for this tap. As I mentioned earlier, we have about 1/3 of the rainfall, 1/3 of the land is set aside, which collects 50% of the rainfall. And most of the catchment areas are already in that 1/3 where the rainfall is most intense, meaning that the remaining 2/3 rainfall is much more diffuse. So siting of reservoirs will be much more difficult. That also makes it much more expensive. In terms of deepening reservoirs or building new reservoirs, the cost can be very high. So on average, the estimated cost for Hong Kong will be around $20 per cubic meter, making it significantly more expensive than any of our other alternatives. If you want to look at it in a different way, though, there are potential for some additional projects if we consider tangential benefits. So when you're looking at like the Interwater Transfer Scheme, or the current project between WSD and DSD to collect more rainfall and divert it during times of flood, you have to consider the co-benefits of those 2 projects. So from a water supply perspective, they might not make sense. At say it's a $15 per unit project, that wouldn't make sense. But if you consider the benefits of flood prevention, which are going to be different depending on the project, it might suddenly make sense. So we can go on. So moving on, since local yield is capped, Hong Kong needed to find a secondary source of water. And in the 1960s, they started purchasing water from China. And then under that agreement, the agreement's changed over the years, but that's not really important for the current discussion. The agreement gives us a cap of 820 million cubic meters per year, and of that we typically use about 640. Only in years where we don't get much rainfall do we get close to using the full 820. But in general, we have quite a lot of freeboard. So because it's the largest part of our water supply, it also makes up the biggest part of WSD spending. And it's increased from about 38% in 1997 when the tariffs were frozen to about 45% last year, according to WSD's annual reports. And because the tariffs have been frozen since that year, what they call the user pays principle. So the amount people pay for water doesn't reflect the cost that they're paying anymore. And that has resulted in WSD not receiving enough money from the public to cover all of its costs, which results in the water having to be highly subsidized. And further, the cost of that water in terms of its per unit cost has about doubled since the 10-year period that we've been in. And that represents about a 6% per year increase. So to put that into perspective, in terms of Hong Kong's general CPI, prices have inflated at about 3%. So if you had $100 in 1998, you'd have $130 about today. unfortunately, the water has been going up at about 6.8% on average. Now, obviously, in some years it's higher, some years it's lower, but this is just the average for the period. So the price is about $181 to that $130. So the price is going up more than we expected to. And as a result, so if you look on the right-hand side, the DONGJIANG water utilization, Hong Kong utilizes about 30% of all the water in this project. But we provide a much more substantial portion of the revenue, about 60%, which makes like our contribution is much higher. But this only represents the direct costs of the water. The main problem is that it's just not transparent enough to see what the true costs are. There's additional indirect costs that need to be considered when you're looking at both sides. So the cost of, say, deferring development in water catchment areas, the cost of setting aside land for water transport systems. But there's no explicit value given to those services. So it's difficult to say how much of that makes up the water price. So the DONGJIANG, as I mentioned, supplies more than just Hong Kong. It supplies a total of 7 cities, including Shenzhen and other cities in the Guangzhou area. So in terms of water stewardship, if we have alternatives that are better, we should be investigating them so the water can be saved for people who can use it more easily. Looking at the UN sustainability goals, these are very important targets to meet, especially in water-stressed areas like we are in China. So the other benefit is, as you become less reliant on this water, we can potentially negotiate better prices as well. So while this is a tap, this is not a drinking tap. So seawater for flushing was put in the 1950s because we were running low on fresh water. So in order to save fresh water for actual potable uses, so uses like drinking and eating, we set this system in place. Sorry about that. Turn off that real quick. I thought I silenced everything. So this is a completely separate system. It's what they call a dual reticulation network, which means we basically have 2 different water supply systems. These waters never mix. They're completely separate. And this system has been very important to Hong Kong because it offsets about 25% or so, depending on the year, of all the freshwater use. So this is a very big piece of our water. It's also a fairly economical method. The price for this is about $4 per unit. So what makes it economical is that Hong Kong is a very condensed, small, densely packed city. But as we expand into new territories, it gets less clear that it makes sense to continue to expand the network, especially with more modern alternatives that we'll talk about later. But as you move further and further away from your supply of salt water, it gets more and more expensive to pump that water. And if we look at an example in Hong Kong, when we expanded the seawater flushing network into the Northwestern Territories, it's hard to say how much their per unit cost is. So we have to look, because WSD only keeps aggregate data, but we can look at the cost from the year before and the year after and say, okay, well, what's the new cost? So it went from about $3.4 to $4.3, which shows that there was a significant increase in cost for that percentage of water. So we know in those areas other alternatives will be much more attractive. And that's where we can start looking more into recycled water, which is one of the problems that WSD has suggested. And recycled water can be broken down into 2 major components. One is the rainwater harvesting and grey water, and the other is water reclamation. So both of these, in terms of Hong Kong, are only really considered for what they call non-potable use. So that's going to be like your flushing, landscaping, building washing, building systems. And what those look like is essentially, there's a lot of different considerations actually that go into that, and they're very site specific. So these tend to be done on site for grey water harvesting and for rainwater harvesting. They're not usually a centralized approach. So things like available land space, rain and water runoff quality in the area, those will affect the treatment costs on your site. So depending on what you want to use it for, it can be very cheap or very expensive. And then how much demand is there on site for that particular item. In terms of Hong Kong, if you look at the different zoning codes, there's about 81 kilometers of land that would be very promising for rainwater harvesting. And using the calculations that WSD has created in the rainwater harvesting guides, you see that can connect about 14.48 million cubic meters a year, which is about 1.5% of the demand. So it's not a significant piece, but it's still offsetting freshwater demand. We do have some examples in Hong Kong. So while we say the percentage is currently 0, it's just that these projects are too small to actually equal up to anything that's countable. So this example is a DSD project in Kowloon City. So they're basically just collecting rainwater runoff. This project was one of their initial ones and was actually fairly expensive. The main problem is the scale was too small. So a smaller scale project, the economics of scale don't work out very well. Their latest project, however, at Happy Valley had a much better footprint. So this one was designed for flood control initially. So you can see, if you've ever been to the jockey club down there, you have the big grass field, and they used to collect pools of water. So in order to prevent that from running off, they created this system that lets it percolate through the ground and enter storage tanks, which are then dispersed over about 24 to 48 hours. But they also set aside a small portion of that tank for actual holding. That way it can serve a purpose of water production and flood prevention. And they send that through a water treatment process and then use it for flushing in the area. So the main issue you're going to have in Hong Kong with water harvesting is the issue of limited space. According to most of the studies in the area, in order to provide a typical high-rise building, you need about 900 square meters, which I believe we figured out was about 2 basketball courts of space as a good visual representation. So in order for a single building to have that kind of free footprint is somewhat difficult. You also have a problem of mixed zoning. As I mentioned before, water quality impacts treatment cost quite a lot. And in areas like Hong Kong, because we don't have a clear residential, commercial, or industrial split, and you can have buildings that have restaurants and auto repair, etc., all on the same footprint, or you can have your building next to a place that's collecting scrap metal for recycling. Those all will impact the costs of doing those kinds of projects. Treated gray water is a bit easier because you know what's going on inside it. And that one is basically just collecting the water that comes from your building waste, but only from the sinks, so not the bathroom. And that is a bit more sustainable as well because it's not susceptible to what you call natural flow, where rainwater harvesting, you still need rain for it to occur. Gray water, you basically have the same daily flows in your building. So you know how much you produce on any given day, and it's a very constant supply. And it runs into a lot of the same problems. You still need space for storage tanks, etc. So in terms of most building owners, without some form of incentive, it's difficult for them to set aside, say, land that could be used for parking or other space, or even, say, local drinking water because it's so cheap. Reclaimed water is essentially the same thing, but using dirtier water. So reclaimed water is using the sewage flow in lieu of harvested rainwater. So this is a completely kind of what they call drought-resistant resource. It's not subjectable at all to natural flows. It's only based on how much wastewater you produce. This actually does occur in Hong Kong right now. We have one place in Nongping in terms of what WSD does, and they use that to provide treated water for the tourist flushing, so the tourist toilets in Lantau. And the main goal of that project originally was to treat water to a high standard for discharge into the area. So as we get greater discharge standards, this will make more sense. Right now, so Hong Kong is not looking at this as a very large resource. They're only looking at it for a very small percentage. So looking globally, we see much more significant potential for this resource than we currently have in Hong Kong. So, of course, the first comparison most people will go to is Singapore. And Singapore has a very similar demand for water as Hong Kong, so it makes a okay case. There's some different politics and things, but it makes an okay case for the business aspects. And if we look at it, Singapore is aiming to use about 40% of their water demand from what they call new water, which is their name for reclaimed water. And they're aiming that for mostly industrial use at the moment. They do have the potential for potable reuse as well through what they call indirect potable reuse, where they'll send it to a reservoir and then have it retreated. So you can see here, they've been working very hard on meeting their challenge of public acceptance. And this is really the main barrier for this resource, is how do we get the public to accept drinking recycled water or using recyclable water. And over the years, because they've had a very good reputation and they haven't had any major incidents, the public is very accepting of this as a resource. Going on to California, so California's had a very long history with recycled water, going back into the 1800s. They are probably one of the most advanced in terms of the US regulatory systems. They have 47 different permitted uses, up to and including recreational uses. So you can use it for fishing and boating in the California area, which is unusual in a lot of places beyond irrigation. But their approach gives municipalities the flexibility to pick what's best for their individual circumstances. So in terms of what Hong Kong is adapting more of, right now Hong Kong is focusing more on desalinated water, which is really still the most common approach globally as well. Most countries are looking at desalination first. And in terms of Hong Kong, what we have is the Chung Kwang O plant, which is supposed to open in 2022 using a reverse osmosis process, and is aimed at doing initially 5%, moving on to 10% of the water supply. So the main problem with desalination is it's a very energy intensive process. In terms of its kilowatt requirements, it can be 6 to 8 times what Hong Kong's local water production is, which means that you're going to have a much higher carbon footprint depending on your mix of fuels. And WSD is already a very large user of electricity, so if they're worried about their carbon footprint, they'd have to be very careful about how much desalination they want to implement. There's also the worry about potential environmental impacts beyond the carbon emissions, which go on to the impacts from brine, which is when you desalinate water, you take about, say, 3-to-1 ratio. So for every 3 liters of seawater you have, you get 1 liter of drinkable water, and the rest gets condensed. So the salt content is much higher, the temperature is usually much higher because most of these technologies are thermally based. You also have treatment and pre-treatment chemicals that can end up in the water, like copper chlorate, I think is the most common one. So there's a lot of studies going on to see what are the long-term impacts of that kind of output as it gets bigger and bigger. So in terms of that, just to sum up, here's a quick snapshot of all the resources in terms of their current unit price, what we feel as their climate resilience, and what we have as like an adaptability. So what's the potential of this resource to meet needs going forward?